Have you ever heard of a piece of tech that sounds like it was ripped straight out of a science fiction movie, but it's actually reshaping our world right now? Well, today, we're pulling back the curtain and demystifying the digital twin. Let's dive in. So, think about this for a second. How do you fix something incredibly complex before it ever actually breaks? I mean, imagine you're in charge of $1 billion factory, or maybe a whole fleet of jet engines. Downtime isn't just an annoyance, right? It's a potential catastrophe. So how on earth do you get ahead of problems like that? Well, the answer lies in this really revolutionary concept that's bridging the gap between the physical and the digital worlds. Let's talk about the digital twin.
Okay, so what is it exactly? First off, this is not just some static 3D blueprint or a simple diagram. A digital twin is a super high-fidelity virtual replica of a real-world thing. Think of it as a counterpart that literally lives, breathes, and changes right alongside the original. But what really makes it so special?
This right here is the absolute key. The twin is alive with data. It's constantly being fed information from all these sensors on its physical brother, which allows it to mirror the real object's condition, its health, its behavior, all in real time. This live connection, that's its secret sauce. That's what gives it all its power.
So how do you actually bring one of these digital doppelgangers to life? It's not just one thing. It's this really cool integrated system with 3 core parts that have to work in perfect sync. You know, the easiest way to think about it is like a body, a brain, and a nervous system. First, you've got the body, which is the physical asset itself, the real machine covered in sensors collecting all sorts of data. That data then feeds the brain, which is the super detailed virtual model that simulates how the asset should be behaving. And then, connecting them both, you have the nervous system. That's the data link, and it's a two-way street. Data flows from the asset to the model, and importantly, commands can flow back from the model to the asset.
All right, so now that we kind of get the architecture, let's talk about what makes them so incredibly powerful. Digital twins basically unlock 3 game-changing capabilities, or as I like to call them, superpowers.
First up, it gives you this almost godlike view of your operations. Imagine a wind farm operator, right? They're sitting in a control room maybe hundreds of miles away, and they can see exactly how every single turbine is performing. And using the digital twin, they can remotely tweak the blade pitch on each one to perfectly match the wind, maximizing energy output literally second by second. It's incredible.
Superpower number 2 is basically being able to see the future. So a digital twin of a jet engine is analyzing thousands of sensor readings from every single flight. It can spot these tiny, almost invisible patterns that signal, hey, metal fatigue is about to start. The airline can then schedule maintenance to replace that specific part long before it ever has a chance to fail. I mean, this is a total shift from being reactive to being truly predictive.
And the third one is like having a risk-free crystal ball. Let's say a factory manager wants to completely reconfigure her production line. Now, instead of shutting down the entire operation for weeks to physically move stuff around and test it, she runs hundreds of simulations on the factory's digital twin. She can perfect the new layout virtually, making absolutely sure it works, all before a single real machine is moved. It's this perfect, safe space for innovation.
Now, this tech isn't just some far-off concept. It's a booming market. So let's take a quick look at some of the key players who are really bringing these virtual worlds to life.
Now, what's interesting is we're seeing these different strategies emerge. You've got an industrial giant like Siemens, and they're focused on the entire factory value chain. Then you have Dassault Systems, who are the masters of simulation, and they're all about creating these ultra-realistic virtual twin experiences. And then, of course, you've got Microsoft providing a super scalable cloud foundation with Azure, which is kind of democratizing the tools, so pretty much anyone can build a twin of, well, anything.
So where is all of this headed? I think it's pretty clear the digital twin isn't just another new tool. It really represents a fundamental shift in how we're going to interact with the physical world around us.
So if you take anything away from this, it's these 3 core shifts. First, digital twins move us from fixing problems after they happen to preventing them entirely. Second, they give us that safe sandbox to innovate without any real-world risk. And maybe most importantly, they create this powerful, seamless bridge between our physical and digital realities.
And trust me, the evolution is just getting started. The next wave is going to be all about infusing these twins with AI and machine learning. So they won't just predict a failure, they'll actually learn from it. They'll prescribe the best solution, and heck, maybe even execute the fix themselves, completely autonomously.
Which leaves us with one last big thought to chew on.
We've talked about twins of engines and factories, but what happens when we scale this technology way, way up? What if we could create a digital twin of an entire city? A city that can manage traffic, optimize its energy grid, respond to emergencies instantly. A city that could literally learn, adapt, and even heal itself. That's the future this technology is building.